Here we have a pre-calculus problem. Okay, let's go to the question. Find the value of a positive 1 when a negative 2 factorial times 120 equals to a positive 1 factorial. Okay, here using this equation, we have to get the value of the expression a positive 1. Okay, here in the given equation, I can solve for a. Once I get the value of a, I can add 1 to the value of a to get the value of this expression a positive 1. Okay, now let me take this factorial equation as it is. That is a negative 2 factorial multiplied by 120 equals to a positive 1 factorial. Okay, now let me consider the factorial of a particular number. For example, let me consider 7 factorial. How can I evaluate the value of this 7 factorial? So to evaluate the value of this 7 factorial, what I have to do is I have to reduce this 7 for the consecutive integers up to 1. That is 7 times, 6 times, or 5 times, or 4 times, or 3 times, or 2 times, or 1. So here I have done all the integers from 7 to 1 and I have to multiply them all to get the factor of this 1, that is 7 factorial. In case if I want to get 5 factorial, what I have to do, I have to write all the integers from 5 to 1 and I have to multiply them. Okay, so when I expand 7 factorial, so I am writing 7, 6, 5 and it keeps going. For example, if I want to stop somewhere in the middle, that is I don't continue up to 1, I want to stop at particular value in the middle, that is 5. So whenever I get, I'm trying to get value of a factorial and I stop at the middle. So the number at where I'm stopping, I must take factorial so that everyone can understand this is continuing up to 1. So for example, if I evaluate 10 factorial, what I have to do is I have to write all the integers from 10 to 1 and multiply them. So let me write 10 times 9 times. Okay, I just want to stop at 8. Since I want to stop in the middle, for this 8, I must take factorial over here. Okay, now let's apply this logic in our problem. Okay, for that we have to consider the two stuff which contain factorial. So here this one a negative 2 contains factorial, a positive 1 contains factorial. And in both these terms, we have a. Okay, which one is smaller and which one is bigger? Clearly, this one is bigger than a negative 2 factorial because here 2 is subtracted from a. Here 1 is added to a. So now what we have to do is we have to consider this one as bigger. So we have to expand this one. So let me write this one and this one as it is on the left side. That is a negative 2 factorial times 120. Now, so we have to expand the bigger factorial. So a positive 1. So what is the next term? For example, if I want to evaluate 7 factorial, first I write 7. To get the next term, I have to subtract 1 from this 7, then I get 6. To get the next one, I have to subtract 1 from this one. To get the next one, I have to subtract 1 from this 5. The same logic. Now, since we are trying to evaluate the value of a positive 1 factorial, first I write a positive 1 as it is. Now to get the next term, I have to subtract 1 from this a positive 1. When I subtract 1 from this a positive 1, I'll be getting a. Now to get the next term, I have to subtract 1 from this a, then I'm getting a negative 1. To get the next term, I have to subtract 1 from this one, I'm getting a negative 2. And it will continue up to 1 like what we have done over here for 7 factorial. But if I want to stop anywhere in the middle, I have to take factorial. I don't want to continue this one up to 1. So I just want to stop at a negative 2. So what should I do? I have to take factorial over here since I stop in the middle. Okay, now in this equation, I find a negative 2 factorial on both sides. So now what we can do is we can divide both sides of this equation by a negative 2 factorial. Okay, let me do it. Okay, here a negative 2 factorial. Okay, a negative 2 factorial here will cancel the same here. Then we get 120 equals to a positive 1 times a negative 1. Okay, here let's consider the product of three values over here. Here we have a positive 1. The second one is a, which is 1 less than the previous term. And the third one is a negative 1. This is 1 less than the previous term. So clearly this is product of 3 consecutive numbers. So now to get the value of this a positive 1, I have to write this 120 also in the same pattern in which we have the 3 values over here. That is, we have to write this 120 as a product of 3 values from greatest to least. Because here we have the 3 numbers from greatest to least. This is the greatest among all the 3. This is the next smaller. This is the smallest. Okay, how do you have to write this 120 as a product of 3 numbers from greatest to least? For that, we have to decompose 120 into its prime factors. Since it's a even number, we can divide it by 2. When I divide 120 by 2, I'm getting 60. Again, it's an even number, we can divide it by 2. I'm getting 30. Again, it's an even number, we can divide it by 2. I'm getting 15. Okay, 15 is a multiple of 3. So we can divide this 15 by the prime number 3. So when I divide 15 by 3, I'm getting 5. So here I got a prime number 5. I have to stop the process. Now 120 can be written as 2 times 2 times 2 times 3 times 5. Okay, here we got 120 as a product of its prime factors. Now our aim is to write this 120 as a product of 3 consecutive numbers. And also those 3 numbers must be in the order from greatest to least. For that, we can consider the multiplication of the two numbers over here, 2 and 3. 2 times 3 is 6. Then we can write this number, 5. Now, we can write the multiplication of these two numbers, that is 2 times 2 is 4. Okay, here we have a product of 3 consecutive numbers from greatest to least. When I multiply 6 times 5, I'm getting 30. 30 times 4 is 120. So now, in this equation, on the left side, for this 120, we can write the product of 3 consecutive numbers, 6, 5, and 4. So then I'm getting 6 times 5 times 4. On the right side, we can write this stuff as it is. It is a positive 1 times a negative 1. Okay, here we have a product of 3 consecutive numbers from greatest to least. On the right side also we have a product of 3 consecutive numbers from greatest to least. Since the product of 3 consecutive numbers from greatest to least is equal to the product of 3 consecutive numbers from greatest to least, so the greatest of the 3 numbers on the left side must be equal to the greatest of the 3 numbers on the right side. That is 6 must be equal to a positive 1, because 6 is the greatest number on the left side. This a positive 1 is the greatest number on the right side. They must be equal. Okay, here I got the value of this expression a positive 1. Its value is 6. And we find this 6 in answer choice A. The correct answer choice for this question is A.